Yeah, so thanks, Patrick, for this great talk. I see two questions in the question and answer bubble, so to say, and I suggest to start with the first one. The question by Masome, asking, usually the output of Gaussian processes is not a smooth function. So it has lots of values and peaks. And if one has data on a property which is behaving smoothly, for example, only a positive and negative deviation from a line, can one use BOS for fitting such data?
Okay, can you hear me? Yes, sir.
Yes.
I must admit, Masome, I don't fully understand the question. So first of all, the output of the Gaussian process is a smooth function. And we can represent functions with many different valleys and peaks. And one hyperparameter that controls this is the length scale that I mentioned in the talk. And this hyperparameter is actually updated automatically in the BOS procedure. So if you have a function that has a lot of fluctuation, BOS can fit it. And if you have a very simple function with not many minima, BOS can also fit that. Anything that is truly discontinuous, that is a problem because we are trying to fit it with a continuous function, and therefore that wouldn't work so well. You would need a lot of points to represent that or change the kernel.
I mean, this would have been exactly my question. I mean, say material science, you usually have, say, phase transitions, right? You have actually, the input is actually discontinuous very often. And so there you say is still some work necessary.
I'm not aware of much work in that direction, but I could imagine that if you build this prior knowledge into the functions that you fit, then this could to some degree be done.
But what would be your input one? I mean, you had an x-axis, right? What would be the x-axis, which is, because, I mean, that's the other thing. You need a good representation for a good description.
Yeah, sure. I mean, so in the two examples that I showed, in one case, the input was clearly labeled, right? So it was the base strength, and the other was the pH value. And that's actually a good example because the base strength usually comes in integers, right? So you don't really have a continuous way of varying that in chemistry, but that doesn't matter, right? If the acquisition function suggests something that is in between two base strengths, you just give it one that is closest, and you can still fit the function. In the other example, we had a 6-dimensional search space. So for the molecule, we kept the molecule rigid, we kept the surface rigid, and then the variables were the X, Y, and Z position and the rotational degrees. So they were quite easy to fit.
So now we have we are running a little bit short of time, so I cannot ask for a short question and a short answer because this question consists of several questions.
Yep.
So I probably will send you the question and you can reply by email later. And so let's thank Patrick again.